Okay, so these examples are a little different than the ones, oh, they are the ones that are in the book, but in the book it's monitoring progress 5, 6, and 7. So let's say that this is 5, 6, and 7. I want you to pause the video and try it. Okay, hopefully you paused it and you tried it. Number 5, linear or nonlinear? Linear. When I first asked you this question, some of you guys answered that this was nonlinear. It actually is linear, and here is why. I'm going to pull apart the fraction, and it's 3 over 5x. And remember, what format should we be able to write it in? Y equals mx plus b. So watch, this is y equals mx plus b. You guys see that? So here's what I'm trying to tell you. A lot of kids don't know x over 2. Pull that apart. It's the same as 1/2 x. Good. And so 7x over 5 is the same as 7/5 x. Okay, I'm going to jump to algebra 2. We did this lesson yesterday in algebra 2. I, imaginary numbers, you'll learn in algebra 2, over 3 is the same as 1/3 I. Great job. Okay, 7. Linear, nonlinear? Nonlinear. Good job. 14 in your textbook. We're going to talk about discrete domain and continuous domain. And you're going to see this mostly in word problems, which we'll do in a few minutes. Okay, discrete domain. And remember, domain is also which values? The x is good. Okay, discrete domains are single input values of only certain numbers. 1, 2, 3, 4, 5. And a very typical word problem on this would be, how many buses do you need to carry 65 students? Well, is it possible to order half a bus? No. So the domain for that one is always going to be discrete. Now, continuous is different. Continuous is all numbers between a certain interval. So it includes 1, 1.1, 1.25, 1.7, 2, 2.999, and a very typical word problem would be something like calories that you're eating. So if a energy bar has 200 calories, is it possible to eat half that bar? Yeah, you can have portions of it. You don't have to have the whole thing. Okay, so that's the difference between discrete and continuous. Okay, and it's always the x value. Okay, so here's example 4. I'm still on page 114. The linear function y equals 1595x represents the cost y, so this is the cost, in dollars of x tickets, so x stands for the number of tickets, for a museum. They can buy a maximum of 4 tickets. Okay, find the domain. Is the domain discrete or continuous? Okay, finding the domain. So the number of tickets. Number of tickets. How many tickets can somebody buy?
4.
Up to 4. So what else can they buy?
1, 2, 4.
Yeah, everything below. Can they buy 0? Yeah, you can buy 0 tickets. That's possible.
Oh, yeah.
You can buy 1, you can buy 2, you can buy 3, and you can buy 4 tickets. So that's my domain. So when I write it, I'm going to write it this way. My domain is 0, 1, 2, 3, 4. Now, is this domain discrete or continuous? Discrete, absolutely, because we cannot buy half a ticket. Good. And then they want you to graph it. So you can plug that into a graphing calculator. Okay, so monitoring progress 8 on page 114. I want you to pause the video. I want you to do it yourself and then check your answer in the back. Okay, I'm on page 115 in your textbook. A cereal bar contains 130 calories. The number of C calories consumed is a function of the number B bars eaten. Does this situation represent a linear function? Yes or no? Yes, it does. Find the domain. Okay, so let's think about it. The domain is, so C calories consumed, 130 for each bar. So this is the number of bars. C is the total calories. No calories. Okay, find the domain. Is it discrete or continuous? Let's do discrete or continuous. Do you think it's discrete or continuous? Continuous. Okay, why is it continuous? Because you can eat half a bar. Okay, so the domain, if you talk about the domain here, I can eat 0 bars, correct?
Yes.
Okay, so it keeps going at 130. Actually, so you can eat 0, you can eat half. Okay, so we're going to write it as x is greater than 0. And in this case, it's not x, it's b. So b is greater than 0. Now, it's also equal to. And I know the example in the book only goes up to 4, but obviously you can eat a whole truckload of bars if you want to. And then when you graph it, if you look at the one that's in your book, it's going to end up being a straight line. Okay, so now you're going to pause the video, you're going to do monitoring progress 9 and 10 on your own, and check your answers in the back of the book.